Hello, everyone. Welcome to the webinar, Modernize macOS Development with Amazon EC2 Mac Instances. I'm Manish Rathore, Senior Product Manager with Elastic Compute Cloud EC2 at AWS. Over the past couple of years, I have been working on bringing this offering to our customers, so really excited to talk about it today.
And
Ravi?
my name is Ravi Murthy. I'm a principal engineer in EC2. I also lead Nitro, which is one of the big things we'll talk about. But we're super excited to talk about this webinar today.
Thanks, Ravi. Awesome. Let's get started. So quickly going through the high-level agenda for today's webinar, we are going to start with why did we choose to build Amazon EC2 Mac instances to support running macOS for our customers. Then we will be going through a high-level overview of how did we build EC2 Mac instances with AWS Nitro, what are the hardware and platform specs, what is the macOS experience like on EC2 Mac instances. Spoiler alert, it's similar to any other Windows or Linux instances that we offer today. Then we are going to cover pricing. And once we have had an overview of these EC2 Mac instances, we are quickly going to pivot to a couple of three common use cases and a demo to get a sense of feel of what EC2 Mac instances offer. We will cover how to quickly get started with EC2 Mac instances, how you can create a derivative macOS AMI, and how you can increase the EBS volume size, which tends to be a common use case that our customers talk about. Then we will conclude and open the floor to any Q&As, any questions that you may have that we can potentially answer. So let's talk about why did we go about building EC2 Mac instances to support running macOS on EC2. As many of you know today, we have more than 1 billion active Apple devices and millions of apps available to the app stores. There is a thriving community of over 28 million developers worldwide who are creating great experiences through apps to delight their customers. Building apps for Apple platforms such as iOS, macOS, iPadOS, tvOS, watchOS, or Safari relies on tooling, frameworks, and APIs that are offered by Apple. Until now, development for these platforms was not possible on AWS Cloud since Apple app development relies heavily on Xcode IDE that is only supported running on macOS. So to be able to support this community and bring them to the cloud, it was clear to us that we needed to build a new platform that can support running macOS. So talking a bit about EC2's history here, back in 2006, we launched EC2 with Linux and Unix support. In 2008, we extended support to Windows operating system. Over the past 12 to 13 years, we had added support to dozens of Linux, Unix, and Windows flavors for customers to choose from, each of them catering to specific workload requirements. As you can see, macOS here is conspicuous by its absence. Bringing macOS to EC2 meant bringing Apple computers into our data centers. As you know, macOS can only run on branded Apple hardware. We were up to the challenge, and thanks to the capabilities enabled by the AWS Nitro system, this is exactly what we did. And I'm now pleased to announce that EC2 Mac instances since last November are generally available for all EC2 customers. Built on Mac mini computers, EC2 Mac instances enable customers to run on-demand macOS workloads in the AWS cloud for the first time ever. So what are the benefits of EC2 Mac instances? We have built EC2 Mac instances specifically with Apple developer community in mind. First, you can now for the first time run macOS workloads on AWS and benefit from the scale, flexibility, cost benefit, and the experience that AWS has to offer secure on-demand infrastructure to millions of customers for more than a decade. Second, Mac instances offload the heavy lifting that comes with managing Apple infrastructure, which means you as an Apple developer can focus entirely on building great apps. No more taking a Mac computer and putting it on a closet or hiding it under the desk. And specifically with the recent remote work situation with COVID, it does take away the pain and the heavy lifting of remotely managing that Mac infrastructure. Third, Mac instances allow you to launch macOS environments within minutes, scale as you need, and only pay for actual usage with our pay-as-you-go pricing. For example, if you have a team of tens or hundreds of developers, you can scale up your build fleet during the weekdays when developers are checking in their code and scale down that fleet during the weekends, which in turn helps you save costs. Fourth, you can now consolidate all your build pipelines and infrastructures across multiple platforms like Apple, Windows, and Androids onto AWS. This leads to lower fragmentation of your development pipeline, which in turn increases productivity and accelerates the time to market. And finally, this is one of my personal favorite. EC2 Mac instances provide you the same experience and ability to access features and services as you would on a Linux or a Windows instances. Similar to other instances, you can easily use Mac instances with services like virtual private cloud for network security, elastic block storage or EBS for expandable and fast object storage, elastic load balancers for distributing build queues, Amazon EFS and FSX for scalable file system storage, and AWS Systems Manager for configuring, managing, patching your macOS environments. With that said, now handing over to Ravi to talk about how we leverage the innovation of AWS Nitro to integrate an Apple Mac Mini computer and offer a fully fledged EC2 instance out of it.
Thanks, Manish. I wanted to spend a little bit of time talking about AWS Nitro and what Nitro has done for us. So back in 2017, we launched Nitro. We actually launched the first instances with Nitro. And if you've used one of our C5, M5, R5, or T3 instances, they're actually built on the Nitro system. What this picture is showing here is a Nitro card. It's a real Nitro card that is connected to, in this case, an Apple Mac Mini, as Manish mentioned. And one of the things that the AWS Nitro system has let us do is offer what we call a bare metal instance. This is not new. In 2018, we offered the i3 Metal instance, which basically is a physical server attached to one of these Nitro cards, and it basically lets customers remotely launch instances on a bare metal machine. So what we effectively did is we said, hey, we've got this cool capability. Let's somehow figure out how to connect one of these Nitro cards to an Apple Mac Mini. And if you look closely at the picture, what you'll see is that the Nitro card, or the Nitro system in this case, consisting of multiple cards, is actually connected to the Apple Mac Mini over Thunderbolt. So if I were to pick up a physical Mac Mini today and flip it around, there's 4 Thunderbolt ports on the Intel Mac Mini, the 2018 Intel Mac Mini. We actually connect the Nitro cards over 2 of those ports. From a customer instance, or from a customer perspective, all of that is sort of transparent to you. What the AWS Nitro system also gives customers is the things Manish mentioned in the previous slide, which is the Nitro cards actually emulate storage, they emulate networking, and they actually let customers launch an instance. So if I were to walk you through kind of what happens when you go to the EC2 console, or when you actually say AWS EC2 run instances, -- instance type is mac1.metal. Effectively, what's happening is the EC2 control plane is routing your request to one of these sleds of hardware that's running the Nitro system and software and firmware. And that is basically taking the request and physically powering on the Mac Mini to run your macOS Army. And effectively, what you get at the end of it is macOS boots up on the Mac Mini. And the significance of this is when we first launched this and we were having these customer conversations, a lot of our customers assumed that we were somehow emulating a Mac Mini or virtualizing a Mac Mini in software. That is not the case. This is physically a Mac Mini running bare metal. So you as a customer are running directly on hardware. So just really quickly, this comes up a lot in our customer conversations. The Apple Mac Mini that we chose to put inside these sleds that I showed you in the previous slide is a 2018 Intel Mac Mini based on a Core i7 processor running at 3.2 gigahertz. It has 6 physical cores, 12 logical threads. And it has 32 gigabytes of memory. The networking and the storage that I mentioned in the previous slide is 10 gigabits per second of networking throughput and 8 gigabits per second of elastic block store throughput. And so when you launch an instance on a Mac Mini, effectively what you see is you will see one or more NVMe controllers, and the Apple macOS NVMe drivers will essentially load and let you access to those NVMe controllers. On the backside of this, the NVMe controllers are really backed by these EBS volumes. So the workflow looks something like you as a customer, choose an ARMY. The ARMY is put on an EBS volume, and the mental model you should walk away with is that the EBS volume is like a USB stick. Somebody is physically going and plugging a USB stick on the back of the Mac Mini into a Thunderbolt port and basically turning on the Mac Mini to say, boot from that thing. So really what you're doing is you're booting off of the EBS volume. And in the same way, the Nitro card is providing networking. It's as if you connected a NIC to one of the Thunderbolt ports, and that gives you the 10 gigabits per second of network throughput. But the more important thing, like Manish mentioned, is that it gives you the capability to be part of a VPC, the virtual private cloud. You can configure like security groups and various other network ACLs and make your instance truly secure. So that's the whole idea behind using the Nitro system to and to normalize it like it looks like any of the other Nitro instances that we offer in terms of look and feel and how you launch these things and how you interact with these things. And then finally, just a little bit about the actual instance, right? One of the things that we focus very, very heavily on during the development of any instance in EC2, and more so in the Mac instance, is we want to keep the sort of interaction, or what we call the customer experience, roughly the same, right? So we didn't want to have to come up with a new API or a new console feel or any such things. We knew that if a lot of our customers that were going to migrate to Mac instances were familiar with our Linux and Windows instances. And so we decided to basically name it in a very similar fashion. The command lines that you're used to just work. Like our existing bare metal instances on Linux and Windows, we offer up to 15 EBS volumes. What this means is you can boot off of an EBS volume, and you can attach additional volumes, up to 15 volumes. We just call them data volumes, and use them for your data, for storing files or build artifacts or whatever it is. The same thing with ENAs. You can attach up to 8 ENIs, and an ENI is basically a NIC. So you can attach 8 of them and run what we call the ENA driver, which gives you that really high throughput networking, up to 10 gigabits per second with VPC and whatnot. The one interesting thing about the Mac instance, when I compare it to like our Linux instances and Windows instances, if you're familiar with them, is as a customer today, I can walk up to a machine and say, hey, allocate me a Linux instance or a Windows instance. And it's a straightforward command line that you launch that effectively launches a Windows instance or a Linux instance. You get an IP address, and you can SSH into your instance and use it. One of the things that we had to do for Mac instances, we had to support this thing called dedicated host tenancy, where you have to do a 2-step. Step 1, you actually have to allocate a dedicated host for yourself. And then step 2 is you have to allocate an instance or launch an instance on that dedicated host. The minimum duration is 24 hours. So when you allocate a dedicated host, it will stay with you for 24 hours. But once you allocate the dedicated host, you can launch and terminate as many instances as you want on that dedicated host. A lot of our customers ask us why we did this. Well, we had to do this because we had to comply with macOS licensing, where we had to make sure there was this minimum granularity of 24 hours when a Mac Mini is allocated to a customer. The other interesting thing about the Mac Mini that sort of differs from our Linux instances and Windows instances is because you as a customer are running on a bare metal machine and therefore have access to like the SSD inside the Mac Mini or NVRAM variables on a Mac Mini. If you have a personal Mac Mini, you can actually go set an NVRAM variable or scribble something on SSD. We haven't modified the Mac Mini at all. We just went and bought it from the store and put it in. One of the things that we have to do is when you leave the Mac Mini, i.e. when you terminate your instance and you walk away from this machine, we can't blindly turn the machine over to a different customer for a variety of reasons. Most importantly, we don't want a malicious customer leaving behind something on the SSD, for example, that can potentially snoop on a different customer's instance when they are running. So From a security bar perspective, we had to absolutely make sure that the SSD is wiped, that all persistent variables are cleared. And one of the things that we do as part of this, what we call scrubbing process, is we also try and update the bridge OS. And the bridge OS is basically the OS that runs on the T2 chip inside the Mac Mini. So effectively what happens from a customer perspective is, let me walk you through these 3 steps again. You allocate a dedicated host, you launch an instance on the dedicated host, and when you terminate the instance on the dedicated host, we run a scrubbing process during which we scrub down the Mac Mini before you get the host back to launch your next instance. One of the other things that comes up very frequently in our conversations is, hey, AWS, when do you launch your launch Mac instances based on the Apple Silicon, also called M1 chip? And we are actually actively working on it. We have the Nitro system. We're actually working on integrating the Nitro system with the Apple Silicon Mac Minis, the 2020 Mac Minis. And we hope that it's going to be coming soon in 2021. So look for that.
Thanks, Ravi. Moving on here to talk about the macOS guest experience. So as Ravi mentioned, just through the innovation of the AWS Nitro system, you can currently spin up macOS Mojave, macOS Catalina, and we recently enabled macOS Big Sur as Amazon machine images. And later on in this webinar, we are going to walk you through exactly the steps and the experience of spinning up macOS Big Sur ARMY on EC2 Mac instances. One of our key tenets has been that we don't do any binary modifications to the macOS that is made available by Apple. It is exactly the same image that would be booting on your physical Mac Mini. But just to make sure that the macOS image works great with AWS and EC2, we do include packages like AWS Command Line Interface, AWS Systems Manager in the ARMY that we provide to you as a customer. And on our public documentation, we list each and every package that is added to the base macOS image to create an AWS ARMY out of it. Once you spin up an instance and the instance passes all the health checks and it is available, there are a couple of ways you can interact with that environment. First is SSH into the instance, which gives you command line access to the environment. Think of it as opening up terminal on physical Mac Mini sitting on your desk. Anything that you can do with the terminal on a Mac Mini, you can do with the SSH access. There are certain use cases like while you're installing Xcode, you need to accept licenses, or if you're trying to define access of file system, grant permissions and whatnot, for which you need a graphical access to your macOS environment. For these, our recommendation is to leverage the inbuilt VNC server within macOS, and as a security best practice, rather than opening the port 5900 on your EC2 Mac instance and directly connecting to that VNC port, which can be a security issue because the traffic is not encrypted, we recommend you to tunnel your VNC traffic over port 22 and avoid opening the default VNC port. And again, one of the later demos, we will show you exactly how to do that. To make the macOS experience even more awesome on AWS and EC2, all EC2 macOS ARMYs come with the AWS homebrew pre-tapped. So all the packages that are installed within the ARMY, you can do a brew update or a brew install to be able to get the latest versions of those packages. Similarly, a lot of our customers on Linux and Unix today rely on something we call Cloud Init to be able to run scripts, run things during initialization, customize that whole initialization process. So for EC2 Mac instances, we built our own EC2 macOS init, which is similar to Cloud Init in its functionality, but works great with macOS. Since we launched back in November with Mojave and Catalina, we recently enabled macOS Big Sur, and as in when Apple keeps on releasing macOS updates, we keep on qualifying them, make sure that there are no regressions, the experience is as expected, no dependencies or no packages are breaking, and we keep on releasing these macOS armies with the latest Apple updates at a regular cadence. As and when we are building our operational muscle and getting more and more experience, we expect our cadence to keep on improving going forward. Wanted to also call out that in addition to new macOS armies supporting latest macOS version, we also support in-guest macOS software updates. So if you are connected via SSH, you can run a sudo software update, or if you are leveraging the GUI, you can actually go and to system preferences software update, get the latest macOS version, install it, and update your instance in place. And once that instance is updated, you can go ahead and create a derivative AMI out of it, which you can use to subsequently launch all the other EC2 Mac instances. Lastly, before we head into the demos, we wanted to talk about pricing. So this question does come up a lot from many of our customers. Is there a separate charge for macOS armies? The answer is no. The macOS armies are made available to you for free, and they are license included, and the charges are only for the underlying Mac dedicated host. As Ravi mentioned earlier, we do have a minimum of 24 hours minimum allocation duration for EC2 Mac hosts, and the billing granularity is on a per second basis. So when you allocate a Mac one dedicated host in your account, that is when the billing starts. The instances that you launch on that dedicated host, they incur no additional charge. It's all being metered and billed for the underlying dedicated host. Similarly, because we have to comply with macOS and Apple licensing here for the minimum 24-hour duration, spot and host reservations are not supported on EC2 Mac instances. The question that our customers frequently ask is, are there additional savings available in lieu of longer term commitment? The answer is yes. Just like our recent generation EC2 instances, we support 1 year and 3 year savings plan. The details are available on the EC2 public pages, and compared to the on-demand pricing, you can enjoy up to 44% savings by buying the savings plan. So that was all the background that we wanted to cover, and we thought it would be really useful for you to know about EC2 Mac instances. Now let's pivot to a few demos that we have prepared for this webinar session. So for our first demo, we will walk you through the steps of allocating a Mac dedicated host in your account, as we talked about earlier, and spinning up a EC2 Mac instance and making sure that you're able to access the macOS environment using SSH and also via the GUI. So to get started here, I'll quickly navigate to my AWS Management Console. Within the services, I will go ahead and select EC2. That brings me to the EC2 console, and on the left-hand side, you will see the dedicated host tab. Just click that host. You will see I have a couple of hosts here, but for the purposes of this demo, I will go ahead and allocate a new dedicated host. So right-clicking on the top, optionally, I can go ahead and assign a name to this dedicated host, just for my own observability amongst the instance type. I can select Mac1 as the family. Instance type here will be Mac1.metal. I pick an availability zone within the region. In this case, it is the Ireland AWS region. And below, I find some options. So I clicked on instance auto placement, and what instance auto placement actually does is assume you have a large pool of number of dedicated hosts. When later you will be launching an Mac1.metal instance, you don't need to specify the dedicated host ID. EC2 control plane itself will go ahead and pick one of the eligible dedicated host and place your instance on that host that it picks. So now I go ahead and click allocate, and now you can see the demo Mac1_2 host is allocated and now available in my account. Now I can go to the top right and click on launch instances onto the host, and this will bring me to the instance launch wizard. I go ahead and selected EC2 macOS Big Sur 11.2.1 ARMY. Instance type is Mac1.metal. As you can see, the network here, the instance is being created in the default VPC for the region. Similarly, it's the subnet, but you can also pick a different subnet based on your requirements here. Going down, you can see like the similar features like shutdown behavior, termination protection, or CloudWatch monitoring that we have for other EC2 instance families. We also support for EC2 Mac instances. It is being launched on the host that we had recently allocated. Now, you can configure storage. You can, the macOS ARMY currently has a default storage size of 60 gigs, but you can also increase the size, as well as you can potentially change the volume type. And similarly, all EC2 Nitro instances support EBS encryption. So that is also something that you can optionally configure on your side. Everything looks good to launch. Make sure that you have access to the private key for the key pair that you specified here. Now, you can go to the console and see that the instance is now coming up. And while the instance is coming up, let's make sure that since you would want to SSH into the instance, you can go to the security tab below, select the security group, and make sure that there is an inbound rule that allows SSH access from your specific computer. So I'll go ahead and there are no inbound rules currently. I'll go and add the rule, which is traffic type is SSH. We recommend selecting your IP here, and that will make sure that once the instance is up and running, all the health checks are passing. You don't see failures when you're trying to remotely SSH into the instance.
Yeah, so Manish, let me jump in here. So I think this is a cool demo because this basically talks about some of the things I mentioned earlier. And mentally, if you think about it, you as a customer went to the console and said, give me a dedicated host. And once you got a dedicated host, you said, give me an instance on that dedicated host. And like you boot your Mac Mini today, instead of booting it from the local SSD, which has Mac OS, effectively what you've done here is you've picked an EBS volume. You can choose if you want the EBS volume to be encrypted, but in this case, you just picked an EBS volume. And then you said, put macOS Big Sur on that EBS volume, and off you go. And effectively, what has happened in the background is EC2 has taken your request, found a Mac Mini somewhere in the region of your choosing, in this case, Dublin, and basically said, hey, let me go. I've got lots and lots of capacity. Let me go place your instance on one of the Mac Minis of my choosing. And here is the image you're going to boot from, and effectively attaches the EBS volume that you picked, the size that you picked, to the Mac Mini, and it says go. And that's effectively what's happening right now. So eventually your instance goes from pending to running, and it takes a little bit because it has to do all these mechanics, and there's what we call EBS hydration happening in the background. But effectively, after a few minutes, you should see your instance come up, and the IP address of the instance in your subnet should be accessible from your local laptop where you did this whole process.
Yep, that is exactly correct, Ravi. So within a few minutes here, as you can see, the instance gets to running state. You can see all the system reachability as well as the instance status checks are passing. That means the instance is now ready for your use. So let's quickly try to SSH into the instance through the terminal running on my local computer. And once you SSH into it, you're greeted. It tells you that you're currently running macOS 11.2.1. And to further validate, we are actually running a physical Mac Mini. If you just run system profiler, SP hardware data type, it will tell you exactly the model, the processor name, the memory available, and everything, even including the T2 BridgeOS version that we talked about earlier. Similarly, you can also look through system profiler, SP software data type, and it will show you the macOS version, the kernel version, and other details for the macOS environment that is running on your instance. So let's take the next steps to get graphical access to the instance. First step there is changing the default password for your instance for the user, EC2 user. And once that process is completed, this is just a warning telling you that changing the password here will not change the keychain password. And you need to call the specific command to change the password and key or the macOS keychain. Next, what we are doing here is starting the default VNC server on macOS. And once the server is up and running, what we'll do is quickly exit. And as we discussed earlier, rather than connecting directly to the VNC port, we are going to tunnel the VNC traffic over port 22 or SSH. So now that the traffic is being tunneled, I can quickly leverage the inbuilt screen sharing app on the macOS device on my side to connect to the instance via localhost. That is not a requirement. If you are running, say, for example, a Linux or a Windows box, any VNC client that supports Apple Remote Desktop or is ARD protocol compatible should be functional in this case. So just going ahead and clicking localhost here, typing in the EC2 user as the username and the password that we just set and signing in. This should directly take you to the login screen for macOS on your EC2 instance. Enter the same password that you recently used. And now this will take you directly to the macOS desktop on your EC2 Mac instance. You get that pop-up because you are connecting via VNC, and if you go to about this computer, you can see it's running macOS Big Sur. Storage is the same as the EBS boot volume size. Exactly the same experience that you would have trying to interact with a Mac Mini sitting on your desk and connected to a monitor. And if you go to the about this computer in the system profiler, you see the Amazon Elastic Block Store or EBS SSD controller.
Yeah, what you should see is you should see an NVMe controller. That's the SSD inside the Mac Mini, which is the Apple SSD. You should also see the SSD controller inside that's exposing an EBS volume, which is what we just saw. And you'll also see that there is a Thunderbolt link that is providing you the network, in this case EN6, which is your emulated NIC that I mentioned in my part of the presentation.
Yep. So once you have graphical access as well as terminal access during SSH, most of the things then become quite simple. You can follow the same process that you would actually um, follow on a physical Mac sitting in your data center or on your desk. Say, for example, you can go here and um, to the App Store, log in with your Apple ID, download Xcode. You can also go to developer.apple.com to be able to download other tooling that you may be requiring or an older version of Xcode. Once you are in with graphical and a terminal access, most of the workflow is exactly the same that you would be used to on a physical Mac computer. So for our second demo, we will talk about creating a derivative macOS army. And that is quite a prevalent use case for our customers. Think of the centralized teams or the system administrators who are responsible for vending macOS images to the end Apple developers within the organization. So the common workflow here is you will start with an AWS vended vanilla macOS army. You will install all the necessary developer tooling, say, for example, Xcode, Jenkins, and other applications or libraries that are required for your workflow. And then you will go ahead and create a derivative army that you or your AWS account owns that you can subsequently use to launch multiple EC2 Mac instances with. So here's the instance that we have launched, assuming it is up and running. You have installed all the necessary applications and binaries for your iOS development environment. Then you can just right click, go to create image, potentially enter a name so that you can recognize the derivative army that you're creating here, give it a name. You can add a detailed description here for your derivative army. Here I have given demo macOS Big Sur derivative. Now the no reboot option here, you can potentially click, which internally what it does is it will not try to reboot the underlying EC2 instance when it is creating a snapshot of your EBS volume to create the derivative army. We do, however, recommend that if there are like any pending IO operations or something that is being written or is in the queue for disk write, just to make sure that the data is not corrupted or the image is not corrupted and there's no behavior, we encourage you to leave the option unchecked. But for the purposes of this demo, we will just click enable, which will tell EC2 control plane to not reboot the underlying instance when creating the derivative image. Here you can change the size. Again, you can potentially bake in multiple data volumes. Like Ravi mentioned, you can attach up to 15 EBS volumes on EC2 Mac instances. So if you want to separate out your root volume with the data volume and bake it into the army, then again, those are the steps that you can perform here. And quickly going ahead, you can also specify the delete on termination behavior. Once you terminate your instance, do you want to keep the EBS volume or do you want that volume to also be deleted? And once you click on create image, you will get a notification that a new army, which is your derivative army, that is being created, and the status will show as pending. When that status transitions to available, that means there is a new derivative army available in your AWS account. So you can use that army to launch all your subsequent instances. Everything that you have pre-baked into the army, all the applications, all the binaries will automatically be pre-installed when you launch a Mac instance with this derivative army. So for our last demo today, we are going to be demonstrating how to increase the EBS volume size on your EC2 Mac instances. As we talked about earlier, the default AWS vended army from EC2 has a 30 gigs or a 60 gigs default size of the root volume. But a common question that we hear from customers and is a common ask is they want to increase the size of their root EBS volume to a higher number. It's the great thing about EBS is it is elastic storage, so you do not need to pre-provision the size of the EBS volume that you're going to be using and paying for. You can keep on extending the size of the EBS volume throughout the life cycle of your instance. As in when you need more EBS disk size, you can keep on increasing that size. I believe a single EBS volume can go up to 16 terabytes of storage. So to increase the size of our EBS root volume on our instance, if you click on the storage tab, you can see that the volume size here is 60 gigs by default. So clicking on the volume ID will take us to the specific volume that is being used to boot this EC2 Mac instance. You can right click, select modify volume, and here not only you can change the size, but also the type of the EBS volume. So here from 60, I'm going to increase the size of the volume to 300 and just click on modify. It may take a few minutes for the EBS volume to, the size change to take effect. During that period, you will see under the state what percentage progress has been made, how much tentatively time is remaining. As you can see, the state change here from in use green to in use yellow, and below it will show you optimizing the performance. And while once the optimization actually completes, you can go back to the instance pane, select the instance, and click reboot. And within a few minutes, once the instance reboots and come back up, the increased EBS volume size will be available to macOS, but we would need to increase the size of the file system to be able to expand and take up the entire storage that is available to the instance. So after waiting for a few minutes, now that the instance is rebooted and it is back and available, you can see all the health checks have passed. You can see the volume size here below in storage is now showing 300 gigs. But if you SSH into it and do a disk util list, you will see dev/dev/disk1, it shows as 322 GB, but the APFS container scheme is still showing 64 gigs. And you can also validate that the APFS container size is 64 gigs by right-clicking on the GUI and seeing get info. The capacity here shows us 64 gigs. And that is because we haven't expanded the APFS container to be able to expand to the available disk space. So we have these steps highlighted or documented in our EC2 Mac public documentation page. The first step that we are going to do is to run a repair disk for the physical disk. You can click yes or Y here. And now it will run the repair disk process. And once repair disk has been run, you can go ahead and run the resize container command. And once you run the resize container command, depending on how large a file system it is trying to resize, it can take from a few seconds to a few minutes. Here we expect it to take a few seconds before the entire process is completed 100% and the container has been resized. Awesome. So the APFS operation has now finished. Now, if you just go ahead and again run disk util list, Now you can see that the APFS container for the boot volume now shows you 322 GB or 300 GIB or gigabits as we were expecting. And now you can, if you go back to get info, you will see that the capacity has now increased to 300 gigs. So those were the details and the demos that we wanted to share with you today. Hope you found them informative and useful. Thanks again and have a great day.